Alright, in this lesson, or in this video, we're going to be talking about a little bit of background information for the sum and difference formulas. And it's going to help us solve problems like, say, what you see down here, cosine of x plus 2. How can we handle that, okay? So we have three formulas, and your job is going to be to memorize the three formulas that we have here. One is for the sine of the addition of two angles. One is for the sine of the subtraction of two angles. We have cosine of subtraction and addition formulas. And we have tangent for addition and subtraction. Now you can see here that most of the difference between the three is going to have to do with the sign that goes in the middle. See, if I add two angles together, say 30 degrees and 45 degrees, then this is the formula I'm going to use. I'm going to use a positive sign. But if I'm taking 45 minus 30 maybe, I would do a subtraction sign in the middle. We can see with the cosine, it actually ends up being opposite sign, right? So if I have the cosine of two things that are added together, I'm actually going to do a subtraction thing in the middle. And vice versa for subtraction, that becomes addition. And then for the tangent, of course, we've got here, it looks like the sign on top is the same, but the one on bottom is the opposite. When I do subtraction, the sign on top is the same, but the bottom is the opposite. And this is going to take a little bit of work to memorize, and you will be expected to memorize it, but that's the general idea. So you want to get used to, what do I do here? And we'll talk about more of this in the coming examples, but for the most part, your job is to memorize. So let's start off with a little bit of comparison. Let's start with the graphs of y equals the cosine of x plus 2 and y equals the cosine of x plus the cosine of 2. Let's compare those graphs and see how they look. So what I've done is I've already got a graphing calculator ready to go. I put the calculator in degrees mode and I'm graphing it from 0 to 360. So my window and everything, I've already set that up before I started recording. When I hit the graph button, well, shoot, hold on a second. Let me put a new thing in here, and let's hit a new thing. So I want it to regraph. Here we go. Here's the cosine of the quantity x plus 2. And here comes the cosine of x plus the cosine of 2. Now we can see they have a lot in common, sure. I mean, it looks like they follow maybe the same period, and it looks like they have the same low points and the same high points, but we do notice that they are not the same graph. And so what we can conclude from both of these questions, are the graphs the same? No, they might have a lot of common, but they're not the same. And so if we asked if these two were equal statements, this statement would, or the answer to that question would obviously be no. They'd have to be the same line, right? Excuse me, I got to sneeze. Whew. Okay, let's do the same thing with y equals the sine of x plus 2 and y equals sine of x plus sine 2. So once again, I have a calculator that I set aside. I have this ready to go. It's like a cooking show, right? A baking show. So I've already put these in. Let me type something new in. Make sure I put that parenthesis in again. There we go. Alright, so now it's going to regraph the lines. Let's compare these two. Same idea. If I take a look, here comes the y equals the sine of x plus 2. And watch very closely. See how the line's going to get thicker here. So that tells us, dang, this got a lot in common. It's pretty darn close to the original graph, but because that line got thicker, apparently those are not the same values. They're off by just a little bit. And so what it means is this. Are the graphs the same? They're close, but the answer is no. They're not identical. And so is it true that these two values, these equations, or the expressions are equal to each other? No, they are not. Now, with that in mind, apparently it's not as simple as saying this is the sine of x plus the sine of 2. In other words, it's not distributive property. It is not distributive property. We need to be able to come up with something else. And it turns out then, the way we do sine of x plus 2 is we say we need to use this formula. The u value would be an x, and the v value would be a 2. It's apparently sine of x cosine of 2 plus cosine of x sine of 2. And that's how we would begin a problem if we needed to evaluate this expression. One more thing that's going to help us out before we get going, just a little bit of math, okay? For example, if I'm going to be working with degrees, I'm going to be working a lot with 45s, 30s, and 60s, right? So 15 degrees, for instance, would be a subtraction problem. I'm going to look at 15, no longer as 15, but as 45 minus 30. Or 15, I can also look as 60 minus 45. Perhaps if I get 75 degrees that shows up in a problem, I want to look at that as a combination of 30 plus 45. Or if I want to look at 105, maybe I'm going to do 45 plus 60. Or if I get 120, I can look at that as 30 plus 90. Now those all make sense, right? That's just simple addition and subtraction. But what we're going to do is we're going to do something like this. Instead of looking at sine of 15 degrees, we're going to say, well, I don't know what the sine of 15 degrees is, but I can find it if I know the sine and cosines of 45 and 30. I'm going to look at that as a combination of 45 minus 30. We can do the same thing with fractions. If we're going to work with fractions, like maybe this is pi over 12 instead of 1/12, we can say, well, 1/12 is 1/4 minus what fraction? Well, I would first want to start by thinking of this in 12. So that's 3/12. I'm going to take 2/12 away, right? Well, 2/12 is the same thing as 1/6. 1/12 is equal to 1/3 minus something. Well, that would be 4/12. That means I need to take 3/12 away. 3/12 is the same thing as 1/4. 5/12 equals 2/12 plus 3/12. 7/12 is equal to 3/12 plus 4/12. And 2/3 is equal to 1/6 plus something. Well, I'm going to put this, I'm going to say that's 4/6 is equal to 1/6 plus 3/6, which is 1/2. By the way, you may have noticed these are equivalent statements. I did the exact same things, except I could have put pi on the top of each of these fractions. Pi over 12 is the same thing as pi over 4 minus pi over 6. 15 degrees is the same thing as 45 degrees minus 30 degrees. And that's the way it should work for all of these, right? So we can start looking at it as a combination instead. Now, if that makes sense, next video should be the first example video. I'm going to start working through some problems to help you through with the notes.